Let's discuss operators more in depth. Python divides the operators in the following groups: arithmetic operators, assignment operators, comparison operators, logical operators, membership operators, and there's a few more, but we'll focus on these fundamental ones in the meantime. As we know so far, operators are used to perform operations on variables and values. Arithmetic operators are used with numeric values to perform common mathematical operations. Suppose that we have a variable that is set to the value of 15, and we have another variable y assigned to the value of 4. We can use the addition operator, the plus, to print the sum between these two variables, x plus y. Run the program. 15 plus 4 equals 19, which is correct. We can also subtract these two variables together. So x minus y, 15 minus 4, and we get 11, the difference between these two values. We can also multiply the variables. X times y using the asterisk, and we get 15 times 4 is 60, which is correct. And that's the product between these two values. We can also divide these two variables together using the slash symbol, x divided by y. Run the program. 15 divided by 4 is 3.75. Now notice in the result we got a decimal result, a float, in other words. If we don't want to get a decimal or a float as a result and we want a whole number, we can add another slash and we get a whole number integer as a result. This is because the double slash is a floor division operator, which means that the result is rounded down and returned as an integer, a whole number integer. Now with the regular division, where we got a decimal or a float as a result, technically speaking, this decimal part is considered to be the remainder of the division operation. Now in some programming problems, we might want to, for example, find out if numbers are even or odd, or if numbers are divisible among each other, things like that. These are very common and important problems that come across in programming. And one special operator that we can use to allow us to determine the results for these kind of problems is what we call the modulus operator. Now, the modulus operator returns back the remainder as a result. So if we were to run the program, we get 3. We can verify this result using a long division calculator. In a long division calculator, we normally plug in the first number, as we call it a dividend, in this case 15, which is the x, and we plug in the divisor. In this case, for example, that would be the y, which is 4, and we calculate, and here we get an answer. So if you were to do this by hand, the answer would be considered the quotient. In this case, the answer is 3. And the remainder is what we see all the way at the bottom, which is 3. This is the 0.75 part. And 3/4 is about 75%, so that's basically 3.75, which is what we got as the float result. So the point being here is modulus is focused on the remainder part instead of the quotient part, the answer. Another example of this, suppose 20 and 4. Let's calculate. And here we get 5 as the answer, and the remainder is 0. Why is that? Because 5 times 4 is 20, so 20 is divisible by 4. And that's why you see the quotient, or the answer here, is 5 and 0. Now there is another operator which is known as the exponentiation operator, and to conduct that you can use 2 asterisk symbols. Run the program, and we get 5,625. So this just means that y is the exponent of x. In this case, 4 is the exponent of 15. By the way, it's important to note that operator precedence matters very much. Operator precedence describes the order in which operations are performed. This is basically like the rule PEMDAS: parentheses, exponents, multiplication, division, addition, and subtraction, if you remember that rule from mathematics. So for example, suppose that we have the following expression: parentheses 6 plus 3 minus another set of parentheses 6 plus 3. In this example, parentheses has the highest precedence, meaning the expressions inside parentheses must be evaluated first. If we run this program, we get 0 here. So the interpreter interpreted the expression as follows. First, it started with parentheses, and whatever was inside this parentheses, the first parentheses, which is 6 plus 3, 9, and then we have minus. But before we proceed with the minus, because the other parentheses takes a precedence first, based on the PEMDAS rule, so we have another 6 plus 3, which is 9. So now both of them are evaluated as 9 and 9, so 9 minus 9 is 0. Now let's explore another example. Here we have 100 plus 5 times 3. According to operator precedence, based on the PEMDAS rule, multiplication has higher precedence than addition, and therefore multiplications are evaluated before additions. So in this case, 5 times 3 is evaluated or precedes the plus 100. So if we were to run this program, the way the interpreter evaluates it is 5 times 3, 15, plus 100. So we get 115. And not 100 plus 5 times 3. So it's 5 times 3, then plus 100, even if the 100 comes first. Now suppose we have another expression like this, 5 plus 4 minus 7 plus 3. Now in this case, we have two operators that have the same precedence, addition and subtraction. So the expression shall be evaluated from left to right. In other words, we first start with 5 plus 4, which is 9, then minus 7, which is 2, and then plus 3, which is 5. And we can verify this by running the program. We do indeed get 5. Now let's talk more about assignment operators. Assignment operators are used to assign values to variables. For example, x equals 5. We've seen this multiple times now. Most of the assignment operators have a shorthand variation that leads to the same result. For example, if I said x equals to x plus 3, we can write this in a shorthand version as plus equals 3. This is the same as saying x equals to x plus 3. This works the same way if we are dealing with the other operators, like, for example, minus, which would be equivalent to the same thing as x minus 3, multiplication, division, and so forth. You probably don't have to worry too much about this right now. This will probably apply a little bit more later when we are dealing with more complex examples, and shorthand variations just make the code shorter and easier to write. Now let's discuss comparison operators. In a previous lesson, we covered data types in Python such as int, float, and string or text. With comparison operators, we now focus on another data type, Boolean. In programming, we often need to know whether an expression is true or false. Booleans represent exactly one of these two values, true or false. Comparison operators are used to compare two values and return a Boolean result based on that comparison. For instance, if we had the variable x equals 5 and another variable y equals 3, and now let's have a print statement like x equals y, run the program, now we get false. Now the equals here is the equivalence operator, which means we're saying is 5 truly equals to 3? Well, it's not, and that's why we get false. Now we can use another comparison operator like not equals to, so using an exclamation mark. And this basically is the opposite of the result. We're saying is 5 not equals to 3? In this case, 5 is not equals to 3, so it should give us true. We can use another comparison operator, one that is quite common, the greater than symbol. In this case, we are saying is 5 greater than 3? 5 is greater or bigger than 3, so the result we should be expecting is true. And of course, the opposite of greater than is less than. Run the program, and of course, 5 is not less than 3, so we get false back. We can also use a combination, so greater than or equal to, less than or equal to. For example, here we can say, is x less than or equal to y? Well, we should be expecting to get false regardless because x is not less than y, 5 is not less than 3, and neither is it equal to it. So we'll get false once again. Now, if we switch it around and we say, is x at least greater than or equals to y? Well, it is greater than y because 5 is greater than 3, so we should at least be getting that part true. And indeed, we do get true. Now, if I was to switch the value of y to, let's say, 5, and run the program, we should also get true back, not because x is greater than y, but instead x is equals to y. Because in this case, we're saying, is x greater than or at least equals to y? This is basically like saying x equals y, which in this case will also give us true, because they are indeed equivalent. Now keep in mind that this is the equivalence operator. One equal symbol means that you are trying to assign a value to a variable. So if I was to say x equals y, run the program, we get a type error. So keep this in mind that when you are trying to compare two variables together using comparison operators, you need to make sure you use the right equivalence operator. In this case, two equal symbols and not one, which the one stands for the assignment operator, not the equivalence. Now, once we have Boolean values, we can combine them using logical operators, and, or, and not. These operators follow clear rules about how true and false are combined. A helpful way to visualize these rules is with what we call a truth table. It's basically a small table that shows every possible input and the result it produces. And represents that it's only true if both conditions are true. Or represents that it's true if at least one condition is true. And not flips the result so true becomes false and false is true. Let's look at an example. Suppose that we have a variable that's assigned to a value of 5, and we're going to have the following print statement. Print x is greater than 0, and, so here I'm using the AND logical operator, x is less than 10. Run the program, and we get true. Now the reason why we got true is because, according to the truth table, AND evaluates as true if both conditions are true. In this case, 5 is greater than 0, and 5 is indeed less than 10. So both of these conditions are true. By the way, notice that we have multiple comparison operators in one print statement. We call this chaining comparison operators in Python. Now let's test if the number is less than 5 or greater than 10. So I'm going to flip these comparison operators around and say x is less than 5 or x is greater than 10. Run the program and we get false. So the reason why we get false is because or returns true if one of the statements is true. So let's check it out. Is 5 less than 5? No, so that's false. Is 5 greater than 10? No, that's also false. So we have false or false. And because none of these conditions is true, we get false because we have false or false. If we had at least one of the conditions true, so false or true, then we'd get true back. For example, let's try to flip one of these less than. So we have x is less than 5 or x is less than 10. Well, 5 is not less than 5, so we already established that that's false. But now 5 is less than 10, so that's true. So we should be expecting to get true because false or true is true. What if we had both of them as true or true? Well, we will get true as well. So for example, if I said x equals 5, run program and we'll get true because true or true is true. Now the result of this expression is true, but we can reverse it using the not logical operator. All we have to do is just write not and surround the expressions with a parentheses, run the program, and we get the opposite of true, which is false. So in other words, not reverses the result of the expression. Next, we'll discuss membership operators. Membership operators are used to test if a sequence is presented in an object. For example, if we have the following list, and by the way, we'll discuss lists more in depth in a later lesson, but for now, just for the sake of the membership operators example, suppose that we have a fruits list as follows. And this is the syntax of writing a list in Python. So we use the brackets operator, and we can, in this case, make it a strings list of a bunch of fruits like apple, And the strings here in the list are separated by commas. So we can have another fruit like banana and another fruit like cherry. So here we want to check if banana is present in the list. So we can say print banana, and we can use in membership operator on the program, and we get true. So here we're saying, is the string banana in the list fruits? So it basically matches it exactly, and hence we get true back. Let's try looking for oranges. Run the program, and we get false. Indeed, oranges is not in the list of fruits. Now, what if I misspelled one of the strings? Like, for example, instead of 2 R's of sherry, I said like 1 R. Run the program, and we get false. So in other words, every letter of the string has to match for the in operator to return true. And just like we have the not logical operator, we also have the not in membership operator. So here we can just simply say not in fruits. So this is the opposite. So we're saying is cherry, in this case with 1 R instead of 2 R's, not in the fruits list, and we should be expecting to get true back this time. Because indeed, this cherry with 1 R is not in the list of this fruit. Now, if I add the 2 R's, so cherry, we get false. A more clear example is, let's say if we were to look for oranges in the fruits list, run the program, and we will get true. Now we get true because oranges is not in fruit. But if we were to say, is apple not in fruits, we get false because indeed apple is in fruits. So the opposite, the not true, is false. By the way, the membership operator also works with basic text strings. For example, if we have the following text, hello world, and we print H string letter, is it present in text? Well, it is. It's the first letter, so we get true. Now, what if we look for lowercase hello? Is it present in text? Well, it's not because it's actually uppercase hello. So if we run the program, we get false. If we make it uppercase, then we will get true this time because the uppercase hello is indeed present in text. So this will match. Of course, if we use the not in membership operator and run the program, we will get false because hello is actually in the text. Now, what if we say Z not in text? Well, we will get true because Z is indeed not in the text.